Okay, so the next problem in the lead code we are solving is counting bits. Okay, so basically here will be given an n. Okay, n is equal to 2, let's say, and we will have to kind of generate the binary numbers for it. Okay, let's say that it's a 2, right? From 0 to 2 we'll have to generate a binary. Okay, so what will be 0 1, what is it, what will be the binary representation of 1, and what will be the binary representation of the 2? Okay, and it is shown here. Okay, and now what is the task here is we'll have to return number of ones that are present in the each binaries. Okay, so here n is equal to 2. If you write it like this, right, 0 1 2, the binary representation will be 0 1 and 1 0. So at the end what we'll have to return is number of ones present in each of the binaries. Okay, so one thing is what we can do is we can simply iterate through this, right? Like we will be knowing the range, correct? It will be from 0 to 2, correct? 0 to 2 plus 1, basically we'll also have to include the 2 also. Okay, for each number we can convert it into the binary. Okay, binary of I. For I in the range of this we can convert it into binary, and then we can just apply the count function, how many ones are there. Okay, so that will give us the current number of ones. Okay, and using the list compression we can build it like this, and we can this will be the answer. Okay, like I mean this is one approach. Okay, and what else we can do is we can make use of the dynamic programming to solve this problem. Okay, so when we say dynamic programming, basically we'll be depending upon the previous outputs, correct? Let's say that in the previous analysis we did some calculation and we got some result. If you are able to reuse it, that's how we call it as a dynamic programming, correct? So now how we are going to use that, like how are we going to use our previous result to get the current result, right? So let's say for example I will take before actually going to the dynamic program, let's understand one thing. Okay, so let's say that I will take an example of 1 1 0 0. What it will be, 0 0 4 8 8. Okay, it will be 12, correct? So now let's say that I'm going to right shift it by 2. Okay, so let's say that if I do the right shift, what it will be, like it will always be like divided by 2. Okay, if I do the right shift, it will be divided by 2. If it is a left shift, if it is, it will be multiplied by 2. You can check here, right? Let's say that I'm doing a right shift. How it would look: 0 1 1 0. What it will be, obviously 4 plus 2, it is a 6, right? It got divided by 2, correct? And similarly when I do the left shift, how it would look: 1 1 0 0 0, correct? Yeah, 5 bit. Okay, so what is this value? So this will be like 0 8 8. This will be 8, correct? 8, and this will be how much, 16, correct? This will be 16. So 16 plus 8 will be 24, correct? So what does it say? If we do the left shift, if we do this left shift, we will get a multiplied by 2, and if you do the right shift, it will be divided by 2. Okay, so now this is one concept that we are going to use it here. Okay, so now what we are going to do is, let's say that let's take a same example. Okay, 1 1 0 0. Okay, and now I want to calculate the number of ones. Okay, let's say that I am going to calculate a number of ones. So what I will do is I will right shift with this by 2. Okay, I will do the right shift. So what it will be, like 1 1 0. Okay, this will be like 1 0 will be removed, and here it will go to the 0. Okay, so now this is our problem. Okay, this is our problem. So what we have done is we have done a right shift. Okay, so and what we got some number, correct? We got some number, and also we already did a calculation for this, correct? So when we start from 0, right? 0 1 2 3, like as we just discussed so far in the list comprehension, we will be doing our calculation from 0 to n, correct? N plus 1. So whenever let's say that currently we are at n is equal to 12, correct? So whatever the off value, like whatever the value we got here, n divided by 2, like when once I did the right shift, n is equal to what happened here, like I mean it will be like divided by 2, it went to 6. Okay, and we already know the answer for 6, correct? We already stored it before. When I'm doing the calculation 12, I might have already done the 6 one. I can read it here basically, right? So whatever the value that was stored in the index, right, I will read that value. We'll check the code, which will be clear actually. So we'll read that value which is already stored, right? So that we'll read. And also when we did a right shift, we lost one bit, because but we'll also still have to consider it, right? What if it was 1? Currently it was 0, that's fine, but what if it was 1, right? So we'll have to consider that, correct? So what we'll do is, let's check whatever the number we had right previously, if it is an even or odd. Okay, or simply we can use a bit operation, like and 1. Okay, like whatever it is, 12 and 1. correct? So this will give us the, if it is an even or odd, or it will simply give us the last bit. We can check if it is a even or odd. If it is a even, we can ignore, actually, we can, it's a 0, right? We are not worried about the zeros here, we are mostly concentrating about the 1. Okay, so if the least significant bit is 0, we'll ignore. If it is 1, we'll consider in the count. Okay, so now to summarize here, so we understood the concept of right shift and left shift. Okay, so it will be like divided by 2, it will be multiplied by 2. Okay, so and as we right shift by 2, as we right shift, right, so we'll be getting a new number 6. Okay, we will be going to a 6 number, and we already did a calculation for 6. We will be reusing it. That's how the we'll be making use of the dynamic shift, dynamic programming here. Okay, so now to check the code, right, so we'll initialize our dpra. Okay, like we'll say like initially everything is 0. Okay, the count is 0. Okay, and now we will start from the beginning. Okay, we'll start our analysis from 0. Okay, and similarly when it's a, it can be like right shift. Okay, but we want a, mostly what we want is an index, correct? So it is like dp of I divided by 2. So let's say that we wanted a 12, right? Let's say that we are at a 12, and we can directly read the value from the sixth index, correct? So that's how we are doing it. So we will be reading it from the previous value, previously recorded values. Okay, and finally we'll be checking if there is either odd or even. If it is an odd, we'll be just adding one more value. That is like, I mean, the least significant bit we lost it, right? We'll add it here. Yeah, that is it actually. So like, I mean, we can just analyze it, how this is working, but this is the main principle here. So we'll be, once we do the right shift and we already know that value 6 is already analyzed, and we can read it from there. Yeah, that's it. Thanks.